Okay, from now let me explain about my predictive maintenance project, which focuses on leveraging reinforcement learning algorithms, specifically deep deterministic policy gradient and proximal policy optimization, to predict the remaining useful life of the aircraft engines. So the primary goal is to optimize maintenance schedules still by reducing downtime and operational costs. So to achieve this, I utilize Apache Spark for distributed data processing and LFS for scaling the training of our the models across Spark clusters. The project integrates real-time sensor data ingestion from InfluxDB and historical maintenance data from MongoDB, ensuring that the models have access to both current and past data for accurate predictions. So let me go through the project structure first. So actually, the folders that I have is config, data, logos, notebooks, scripts, source folder, and also I have tests. So actually, the first one that I have done is actually I downloaded the raw data from the Kaggle, so which integrates lots of the raw data sets that is test and train truth data set for training our models and evaluate. So what I have done is actually after I downloaded the raw data, then I pre-processed it actually with data exploration to the notebook. So the notebook performs initial data exploration on the aircraft engine predictive maintenance data set. The objectives are to understand the structure of the data, identify any missing values or anomalies, and visualize key features to gain insights into the data set. So this is what I have done. So actually, I did the raw data set and also show it as a table. Okay, so this is the data set that I retrieved, and also after that, I tried to examine the structure of each data set, including the number of rows, columns, and data types. So this is the rows, and also this is the data types of each column. And yeah, this is the test data. And also, I checked the missing values. If they have some missing values, then we needed to fill in each with average values or more calculated values. Yeah, so this is the missing value data. But however, I don't have any missing values in the training and testing data. And also, I provide a statistical summary with different rating and also describe. So actually, this is the statistical data set that I have, the count being standard, being also the other data sets. And I also visualize the data here. And this shows the correlation between each sensors and data sets in the columns data set. Also, I visualize the sensor readings over cycles for a single engine helps in identifying trends and anomalies. Also, I identify sudden changes for sparks in sensor readings to indicate potential failures or maintenance events. Yeah, so this is the dataset that I have. And after that, I saved the visualization into this PNG file for the future investigation. And what I have done next is I process data. So actually, here I processed the train data into the MongoDB and also test data into the InfluxDB. So actually, this makes the file as the process. So actually, what I have is the train processed and train test processed data sets. Okay. So after I calculate these files, then I implement the feature engineering here. So the feature engineering performs the process data set. Their objectives are to enhance the feature quality, visualize feature correlations, determine the feature importance, and prepare the data for mining. So I visualize the data here. Also, I calculated the correlation between each calculated columns. Also, I provided some visualization between the correlation heat maps here. Also, I try to find out the importance of the columns which you can impact to the RUL. Okay, so these are the values that I have. And, and then what I have done is actually I built the real data ingestion and stream real-time pre-processing data. So actually, when I did the data ingestion, as I said, the data is saved to the MongoDB and InfluxDB. So actually, MongoDB is for the test data that includes the historical data, and the InfluxDB is used for uh, utilizing the real-time data. And after that, I implement the RL environment. So actually, which is used for developing their T, DDPH and PPO models. Okay, so actually here I defined other environment for testing our models and actually using the DDPH and PPO models. So actually in DDPH I create the noise, actor, and critic, and PPO model I create the PPO policy and used it in the other environment. So by using them, I calculate generate models, and the results are the DDPH actor model and PPO policy echo H5. After I calculate these files, then what I have done is actually the model is training is also done by the Jupyter notebook file that I created. So here is the episode reviews over time, and here is the episode rules over time. Okay, so I have only the reviews and no losses over time. So and after that, I calculate the evaluation of the each model. So this is the confusion matrix for DDPH and confusion matrix for PPO. Also, I calculate the actual RUA versus predicted actions for DDPH. Yeah, so it seems it is really better. So finally, what I have found is the DDPH models are better than the PPO models because they provide the higher F1 score based on the evaluation, as you can see here. Also, it effectively balances precision and recall, indicating reliable maintenance predictions, and slight under prediction of RUA suggests the predictive maintenance approach. Yeah, so that is the thing I have done in my project, and yeah, I think that is everything I want to explain in this stage. Yeah, thank you. Thank you for watching.